Hey folks, this is a video just to go over the real-world skills check that we had done. There were a few questions on it for folks at remote as well as in class, so just wanted to kind of go over it here so that we, if you had a mixed understanding of it, we can kind of improve upon that. So the first thing I'm going to see is just kind of read through my problem situation and then try to get a graph going or a rough sketch, which I think people are de-emphasizing. They're not thinking it's as important as it is, when in reality it kind of helps frame the rest of the question. So the moon phase is currently, as of yesterday, a waning crescent with 11% illumination. The illumination percentage ranges from 0% to 100% in the span of 15 days. Create a graph for the problem situation. So, in actuality, the only point that we know, we can do some marking up of our axis here. So we have something that's going to go from 0 to 100, and maybe I'll just keep this as 100 versus 100% because that's a little misleading. So I'll say from 0 to 100. I know my graph is going to oscillate between those two. And the point that I know on this graph is that currently we are at 11%. Okay? The other piece of this, which was a little bit hidden, is that it's a waning crescent, which means that the moon phase is actually, or the illumination is actually still decreasing for a period of time. So we can expect this to be decreasing, go down to 0, come up, hit 100, go down to 0, come up, and then it's going to keep, conducting this repeat over and over again. The other portions of this that we'll need for our equation is we need to know this distance, okay, which would be our period. And what I know currently is that halfway is going to be 15 days. So we're doing this in the span of 15 days, ranging from new moon, which is 0% illumination, to 100% illumination, being a full moon. So that takes 15 days. So our full period then is going to be 30 days. So that question does exist down here, so I'll just say, okay, that's 30 days. Our amplitude is going to be the distance from our midline to our maximum, or our midline to our minimum. So in this case, our amplitude, this distance, is 50, and that's because, it kind of goes hand in hand. So our amplitude is 50 and our midline is 50, because, here the midline always has basically that, whatever that y-coordinate is for the midline, that's what's our midline going to be. And then our amplitude ranges, 50 plus or minus that midline. So this ends up being the information that I need. This is almost everything that we need to create our equation. The, components that I would highlight is, if the question is what is the period, that is my answer. It's 30 days, okay? But that piece of information isn't going to plug directly into my equation. So I do need to use my period in order to come up with my b value. And the equation, or the relationship between those, is that the period is 2 pi over b. So if I want my period to be 30, and I have this 2 pi over b situation, I can do this little switcheroo, end up with b equals 2 pi over 30. And some folks simplified this down to pi over 15. You can also leave it as 2 pi over 30 if you want. And then in my equation here, y equals a sine b of x plus c plus d. I know a lot of these pieces of information from what I already have. I definitely know my b value because I already explicitly solved for it. But what I can also say is that my midline is my d value. That's my vertical shift. So midline is d, and then my amplitude is my a value. So this equation now looks like 50 sine My b value is pi over 15 x plus c plus 50. Okay, so we're almost right there. The piece of this that we're missing, as we can kind of see, is we don't know what the phase shift was or what the horizontal shift was. So, if I go to graph this on Desmos right now, and, I don't have that C value in there, it's going to assume that my moon phase is currently at 50 because sine always starts at the midline. What we want to do, and what kind of the remaining task is here, is we need to plug this into Desmos, add a slider for your C value. So we're going to add a slider for this. And then you're going to slide your graph until we hit this point in particular. So we need your y-intercept to be as close to 0, 11 as possible. And we also need that graph to be decreasing at that point in time. Okay? That is going to tell you your C value, and then we'll have a completed equation. Once your graph is complete, in order to figure out when the next full moon is, I would just say on Desmos, look for the next 100% or the next maximum on your graph once you have the correct C value in place. All right. What illumination percent will there be on your birthday? Well, this is going to change for everybody. And you can do kind of a Google search to figure out how many days your birthday is. So we can just say set x equal to your days away from birthday. And then you're going to plug that into our equation, again, once we know that C value. All right, so hopefully this kind of gets you further along / finished up with this. And yeah, let me know if you have any questions. Thanks.